Okay, video number 2 is going to be the exponential stuff. So hopefully it'll be shorter. Video number 1, those graphs. That's why I told you to only do 2 graphs at most, because otherwise it can be a little daunting. All right. So first thing that I would do with this first problem is I would put a little 1 right here. And I'm going to distribute my exponent. So this is going to be -1 to the -3rd, h to the -6, j to the -9. Make sure that you distribute the exponent to everything. And then so then we have our -2 h to the 4th, j to the -2nd, k to the 3rd times -2 h to the -1, k to the -2. Okay, I can't combine anything here, so I look at my things that I can combine here. -2 times -2 is going to give me a +4. I have an h here, h to the 4th and h to the -1. That's going to be h to the 3rd. I have j to the -2nd, no other j's, so this is going to be j to the -2nd. I have k to the 3rd and k to the -2nd, which is just k to the 1st. And here I have a -1 to the -3, h to the -6, j to the -9. All right, I combine everything. So I have -1 to the -3rd. 4 stays down here. H to the -6 and h to the 3rd ends up being h to the -9th because I subtract my exponents. J to the -9 and the -2. Well, -9 minus -2 is going to be -7. And then I have my k down here. Now it said it should only have positive exponents. So to move my exponents, I have to actually move everything. Everything comes down. So this ends up being, there's only 1 on top, -1 to the now positive 3rd, h to the +9, j to the +7, and k. Now -1 to the -3rd is -1. So this is going to just be negative. Oh, and I dropped my 4. Don't drop the 4. Sorry, 4 should be here. So this is -4, h to the 9th, j to the 7th, k. And that's going to be your final answer. This next guy over here, I like to distribute my exponents first. So that's the first thing I'm going to do here is this is going to be distribute this exponent here, here, and here. So that's m to the 4th times n to the 2/3 times p to the negative. Now that's going to be 6/4 when I distribute. And 6/4 is 3/2 times n times m to the -2/3 times p to the -1 over, and then I distribute my exponent here. So that's going to be m to the 29ths, n to the -5/12, and p to the -5/3. I then combine my terms in the top. So I have m to the 4th and m to the -2/3. Okay, so I have 4th minus 2/3, okay? So this is for my m, which is going to be 4 is 12/3 minus 2/3, which is going to be 10/3. I have n to the 2/3 and n to the 1st. So for my n, that's going to be 2/3 minus 1, which is 2/3 minus 3/3. So I can move this. So this is m to the 10/3. That's 2/3 minus 3/3, which is going to be n to the -1/3. Oh, is it plus 1? Oh, it is plus 1. It's positive 1. Sorry. Plus 3/3. There we go. Which is going to be 5/3. And then we have p. Now p is going to be negative 3/2 minus 1, which is the same thing as negative 3/2 minus 2/2, which is going to give you negative 5/2. So that's what's left in my numerator. My denominator is m to the 20 over 9, n to the negative 5 over 12, and p to the negative 5/3. Then I continue to combine using subtraction because there's division. So it's going to be 10/3 minus 29ths, which is 30/3 minus, or 39ths minus 29ths, because I find a common denominator, which is going to be 10/9. So that's going to be m to the 10 m to the 10/9. So that's how I got that. N is going to be, that's going to be 5/3 minus negative 5/12, which is 5/3. If I multiply that by 4 is 20/12 plus 5/12, which is 25/12. And the last one is your P. So that'll be over here, is negative 5/2 minus negative 5/3, which is negative 15/6 plus 10/6 is going to be negative 5/6. And so there is our final answer. Just a few more of these. So this right here, if I rewrite it, this is the cubed root of 64. Always take the root first and square it. The cubed root of 64 is 4, and 4 squared is 16. This next one's a little bit more complicated. I change my base. Once I have the bases the same, I know x squared plus x is equal to 1/2. X squared plus x minus 1/2 is equal to 0. I can't factor it as is. I could, in theory, multiply each side by 2. So that would be 2x squared plus 2x minus 1 equals 0. But that's still not factorable. So your answer is going to be x is equal to 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 1 all over 2 times 2, which is equal to 2 plus or minus the square root of 4 plus 8 is 12 over 4. I simplify my radical. 2 plus or minus 2 radical 3 over 4, which I could simplify these 2's out with 1 2 out there. So you could also have 1 plus or minus radical 3 over 2. So either of these are acceptable. See if you can change your bases to the same thing. 243 is 3 to the 5th power. 9, that's 1 over 3 squared to the negative u is equal to, and 27 is 3 cubed to the negative 5u. It's 3 to the 5th, 3 to the negative 2u. Or actually, sorry, I got ahead of myself. 3 to the 5th, this is 3 to the negative 2nd to the negative u is equal to 3 to the negative 15u. 3 to the 5th, 3 to the 2u is equal to 3 to the negative 15u. I add my exponents, so it's 3 to the 2u plus 5 is equal to 3 to the negative 15u. 2u plus 5 is equal to negative 15u. 5 is equal to negative 17u. Divide by negative 17, divide by negative 17, u is equal to negative 5/17. And last but not least, this of course is going to be 2 to the negative 2. This is 2 squared to the 3d is equal to 1. 2 to the negative 2 times 2 to the 6u is equal to 1. I add my exponents, 2 to the 6u minus 2 equal to 1. 2 to the 6u minus 2 is equal to, now I can make anything that's 1 as an exponent to the 0 power. So 6u, or sorry, I'm writing u, d, there we go. 6d minus 2 is equal to 0. 6d is equal to 2. d is equal to 1/3. And that's your answer there. And that's it for the exponential.